Okay, so this video is the first part of a three-part series on systems of linear equalities or linear equations in two variables. So a system of linear equations in two variables, x and y, is typically the variables that we're going to be using. It consists of two equations in the form ax plus by equals c, dx plus ey equals f. Here, a, b, c, d, e, f are just coefficients, so they can be any number, positive, negative, 0, could be fractions, could be decimals, it doesn't really matter. The solution of a system of linear equations in two variables is an ordered pair, x comma y. We have to know what x is and we have to know what y is, and it has to satisfy every equation in our system. So in example 1, what we want to do is check whether the ordered pair 2, 2 and the ordered pair 0, negative 1 checks whether or not these ordered pairs are solutions of the following system. So I'm going to start off with the first ordered pair. I'm going to do that one in green. And what I want to do is check it by plugging into each equation in my system. If the equation in each system, or if each equation is true, then 2 comma 2 is a solution. So for the first equation, I have 3 times 2 minus 2 times 2 equals positive 2. And I want to just see if that comes out to be true. So I have 6 minus 4, and that is in fact 2. So we know that ordered pair works for the first equation. Let's check the second equation now. So I have 2 plus 2 times 2 is supposed to be equal to 6. So 2 plus 4 is in fact 6. I know that for a fact, so both equations are true. So yes, the ordered pair 2 comma 2 is a solution of this system. Let's check the ordered pair 0, negative 1 now. Same idea, we're going to plug that ordered pair. X goes into each x of the equations, and the negative 1 goes in for each y in each equation. Okay, so we have 3 times 0 minus 2 times negative 1. And that's supposed to be equal to positive 2. Let's clean it up. 3 times 0 is 0. Negative negative is positive, so plus 2. 0 plus 2 is in fact 2, so that works. Check the second equation now. So we have 0 plus 2 times negative 1 is supposed to be equal to 6. Well, positive and negatives and negatives, so I have negative 2 is supposed to be equal to 6. That doesn't work, so this equation doesn't work. Since the ordered pair 0, negative 1 does not work for both equations, it is not a solution of this system. Again, it has to work for both equations in the system to be a solution of the system. One of the easiest ways to solve a system of equations is by graphing. So that's why we're doing in example 2. Of course, if we're going to graph using our calculators, we have to get each equation, we have to have y by itself. So we do have a little bit of scratch work to do first. So I'm going to do the scratch work for the top equation in green. So I'm going to just rewrite it so I have some room. 2x minus 3y equals 1. Okay, so I'm going to try to get y by itself. So my first step is to move 2x. I have minus 3y equals 1 minus 2x. Now I want to get y by itself. So I'm going to divide by negative 3 on both sides. Cancel out, so y equals 1 minus 2x over negative 3. Now, y is by itself, but before I type it in, I need to remember that every time I have a fraction with more than one thing on top or more than one thing on bottom, I've got to put parentheses around it before I put it in the calculator. Okay, so if you don't put those parentheses everywhere you see more than one thing, it's not going to graph correctly. Let's do the scratch work for the bottom equation in blue. I've got to get y by itself. I'm going to start off by rewriting the equation again just so I have some room. So I want to get y by itself, so minus x each side. Cancel out, so y equals 3 minus x. Okay, so I'm going to go in order, top to bottom. So I'm going to call this y1, this y2. And I'm going to graph these and see what my graph looks like. If you have anything else in your calculator, go ahead and clear it out. So 1 minus 2x inside the parentheses, that's the 40, divided by negative 3. y2, I have 3 minus x. Graph it. And what I'm looking for now is like we've done all semester really, is we're looking for the point of intersection. So right here it is, second count, option 5 for intersection. First curve enter, second curve enter, and then guess you want to move your cursor to position. So nothing has changed really using this graphing technique. But this time though, before when we did graphing, we were only looking for x's. Since we have a system of linear equalities linear equations, I should say, in two variables, x and y, we have to know what x is and what y is. So our answer is x equals, and I lost my calculator, x equals 2, y equals 1. This is my answer. You've got to have both numbers, and it's an ordered pair. Be sure you put a comma in between those two. And as you just seen, a system of linear equations can have one solution. They can also have infinite or no solutions, okay? So we want to know how many solutions in example 3 each of these systems have. So example 3 and example 4, that's what we're trying to do. I want to do this by graphing because we don't know any other method yet. Again, I need to do some scratch work. So top equation is going to be in green. I'm going to get it by itself. I have 3x minus 2y equals 6. Get y by itself, so minus 3x. Cancel out, so negative 2y equals 6 minus 3x. And then divide by negative 2. Cancel out, so I end up with y equals 6 minus 3x all over negative 2. But again, when I graph this, I have more than one thing on top, so it has to be in parentheses when I graph it. All right, the second equation, I'm going to do my scratch work in blue. So I start off with 6x minus 4y equals 12. Get y by itself, so minus 6x both sides. Negative 4y equals 12 minus 6x. And now I want to get y by itself, so I'm going to divide by negative 4. Cancel out. So I end up with y equals 12 minus 6x all over negative 4. But again, when I graph this, I have more than one thing up top, so I have to put the top inside parentheses. Otherwise, I will get the wrong picture. It doesn't really matter which one I put in y1 or y2, so I'm just going to go ahead and graph this now. Again, clear out anything else you already have in there. So I have parentheses 6 minus 3x divided by negative 2. And then I have parentheses 12 minus 6x divided by negative 4. Okay, so graph it. And it looks like I only see one thing, but I know I graphed 2, so I'm going to actually go to my table, and I see that my y1 and y2 are exactly the same. What that means graphically is that these two lines, the green line and the blue line, are sitting perfectly on top of each other. So that means there's an infinite point of intersections. And what that means is infinite solutions. Again, this 8 on its side is the symbol for infinity. So we have infinite solutions when the lines sit on top of each other perfectly. Okay, example 4, I'm going to do the same idea. I need to do some scratch work because I'm going to do this by graphing. Okay, so now we know we can have one solution or infinite solutions. Might be other possibilities, we'll see. Alright, so I have 3x minus 2y equals 6. I want to get y by itself, so minus 3x. So minus 2y equals 6 minus 3x. And then divide by negative 2 on both sides. So I end up with y equals 6 minus 3x all over negative 2. Now, when I graph this, I have more than one thing on top again, so again, it has to be put in parentheses, otherwise it's not going to come out correctly. Put in the bottom equation, scratch work in blue, have 3x minus 2y equals positive 2. Get y by itself, so minus 3x. Cancel out, so negative 2y equals 2 minus 3x, and then divide both sides by negative 2. So y equals 2 minus 3x all over negative 2. Again, when I graph this, I have more than one thing on top, so it has to be put on parentheses. Now I'm ready to use my calculator and graph. I want to clear out that ink from the previous problem, clear out all my other stuff from the previous problem. So I have 6 minus 3x divided by negative 2, and then 2 minus 3x, close it up, divided by negative 2. I'm going to graph this. And I can very easily see that these are parallel lines. Parallel lines, you should know automatically, means that there's no points of intersection. So that means no solutions. So what we've seen now is that a system of linear equations in two variables is going to have one solution, infinite solutions, and no solutions. Okay, so those are the three possibilities. For linear equations, you're never going to have more than one unless it's infinite. Okay, and don't forget, no solutions means parallel lines. That's it for this video. If you got any questions, please let me know.